Hello, everyone. This is Alan Schimmel, DevOps.com, and welcome to another DevOps.com webinar. Today's webinar is actually part of a series, a webinar series we're going to be running called the 5C series. We're doing it in conjunction with our partners and sponsors of this, nClouds, and it's 5 C's that change the future: CI, CD, containers, cloud, and culture. Big five. Each one of these webinars will be standalone in that, if you didn't hear the other ones, you'd still get a lot out of the standalone. But it would really be best if you were able to catch all three of these. So if you look up on your screens, hopefully you are seeing the dates for all of these webinars, and you can mark them in your calendar. You can even go on our site and register for them right now, and you'll get reminders. But important. Please, take note of the dates. But as I said earlier, you don't have to worry about those today. Let's listen. I think today we have a great webinar kicking off this series. Before we get started, though, I wanted to take a moment and just go over our GoToWebinar control panel. We've set aside plenty of time for questions at the end of today's webinar. So we're going to ask, though, that you use the questions section of your GoToWebinar control panel, which for most of you will be in the top right-hand corner of your screens. You could ask your questions in real time. This way, A, you don't have to worry about forgetting them if you're like me. B, they're queued in chronological order, and we do try to follow some sort of chronological order. And C, it avoids the mad rush at the end where some people are dropping off because they don't want to listen to the questions. I don't know why, as those are the most interesting parts of these webinars sometimes. Or, everyone's typing at once and we don't get to them all. So please take your moment as you're listening to this. Question comes into your mind, type it in, it's saved, it's there. And extra special bonus, if we have too many questions and we don't get to it today, we have a written record of it. We can get it to our panelists, and they will try to answer your questions maybe via email, or we can put it up with the recording of this when it goes up on DevOps.com and our YouTube channel, DevOps TV. That actually brings me to my next point. First question always is this webinar being recorded? Yes, it is. The webinar and the slides will be available. We do have to get an approval on the finished recording. So usually we try to get these up in 24 hours. For this particular webinar, we're shooting for 48 to 72 hours or thereabouts. But it will be available, I assure you. So we are recording that. Finally, bottom section of the webinar control panel is the section marked chat. Our chat section is for technical support. If for some reason the slides are not advancing, the audio is going in or out, please feel free to type your problem, if you're able to, type your problem into the chat section of the GoToWebinar control panel, and we have engineers standing by who will hopefully, or at least they'll do their best to try to rectify your problem. So with that being said, let's jump into today's webinar. Faster innovation with confidence, how CI, CD, and containers helped Arrayent go faster. And we have 3 excellent panelists today. First, let me introduce you to JT Geary, CEO and co-founder of nClouds. JT, welcome.
Hey, thanks, Alan. Glad to be here.
That's our sound check. It's working well. Secondly, we have Doug Cleash, solutions architect with AWS. Doug, welcome.
Thanks for having me, guys.
Sounds great. Thank you. And last but not least, we have Jared Sinclair, chief architect of Prodea Systems. And not to get confusing, Jared can tell us more about that. Jared, welcome.
Hello. Thank you. This is Jared.
Okay.
Looking forward to it.
Thanks, Jared. Sound good. All right. So with that being said, let us dive in here now and understand more about faster innovation with confidence, how CI and CD containers help Arrayent go faster.
Great. So thanks, Alan. We're excited about doing these 5C series with you, bringing forward nCloud's customers and AWS partners to kind of show some of the successes we had and some of the tough lessons we learned, and which are intended to hopefully help others. What I particularly like about Arrayent's story is that the impact DevOps had on their business, especially in such a competitive market as IoT. And we've been part of their team for almost a year now, and we could tell you that it's been an exciting ride. And maybe, Jared, we can start off with when you first engaged with nCloud back in 2016. What were some of the challenges you had, and maybe give a glimpse of how things look right now?
Sure. One of the biggest challenges we're facing is that in April of 2016 is just the release time. So as major new features were getting built into our platform, it would take anywhere from 3 to 6 months to get those new releases fully out to production and rolled out to customers. And part of that was just that it was a major event to perform an upgrade, and usually involved everyone from operations getting into it, and then sometimes having to do rollbacks, which meant having to repeat it again at some weekend in the future once we figured out what the problem was. But then it also resulted in low confidence. So we had to spend significantly more resources on quality assurance to try to eliminate that operational impact of having to do rollbacks. And then just the challenges of managing multiple data centers, the security, but also we had some funding challenges. I mean, we're a startup, and we're going into a funding cycle, and so we really had to kind of tighten our belt. Fast forward to where we're at today. Next slide. We're able to get to a point where, actually, if you just get back to one, where we're at right now is that we're able to go from coding to production same day, and that's something that we couldn't have dreamed of when we first started this. I mean, even though I should say that was part of the original vision, but it was just as an organization, it seemed like that was something that would be impossible. But through that, we've actually got a significantly reduced defect rate. The number of rollbacks we have a rollback is pretty much unheard of, because we're able to really manage the change control process, and that's given us the flexibility to really support our customers and meet the demands that they have on our platform. But also given us the bandwidth to do a lot of modernization. One of the big side effects of all this was that we had a fairly large platform, but there was quite a few pieces of it that needed to be modernized or expanded upon. But just with how long it took to do normal deployments, we just didn't have the bandwidth to do that, and it now provides the ability to do that. And it really, one of the big benefits of it is it changed the culture here. I mean, it became a fun, exciting place to work that people enjoy. And net result is that because of our ability to adapt to change, it made us look good to where we were able to get required.
Yeah, that's amazing, and congratulations on that.
Yeah,
and,
thanks.
Yeah. So maybe if you read, like, let's say, a DevOps handbook, there are hundreds of similar case studies, right? I think our audience is probably interested in the strategy we use to get this far. So can you maybe talk on that?
Yeah. So I think what we had to start out with is, a bunch of people, we knew we wanted to jump into Docker, right? I mean, I'd used Docker at some of my previous positions, and I knew what its capabilities were. But there was still a significant pushback because they were like, hey, this is a really big application. It's complex. It's hundreds of thousands of lines of code. Is it really possible to Dockerize something like this? And there's multiple applications that go along with it. So, we initially started trying to integrate this into our normal process control. But what we found is that that really didn't flush very well, and so we started with how do we build a localized environment that would allow us to kind of prove out some of those initial challenges of, is this even possible? And if you can go to the next slide, one of the things that we came across pretty quickly is, well, let's just try to get something that runs local and just demonstrate, what we call the art of the possible, and just say, hey, help the team gain confidence in what we're actually trying to do, and show that, this isn't something like pie in the sky, but this is something legitimate. And so we started with a Docker Compose that would be able to build static containers. And then we set up a simple repo with that, with those containers, and then we gave the instructions to our CEO. And our CEO, in the course of 20 minutes to an hour, I don't remember the exact time, he actually was able to go through this with us watching and able to run our core stack on his laptop. And that was after a week-long hackathon with the team. And that right there kind of signaled, hey, you know what, this is possible. And not only that, management got behind it because they realized, wow, this is powerful, because typically it had taken operations weeks to build out a configuration for an environment, and now here he was running it on his laptop. And so that really made a big impact on how we looked at this and how we were able to do it. And then it also allowed us to figure out, hey, this is something that's important enough that we need to pause our normal R&D pipeline to try to get critical mass on our DevOps effort, and then figure out how do we redesign how we do R&D in order to incorporate it.
Yeah. So, Jared, that's really powerful because most of the DevOps initiatives could take years, right? So it's kind of important to pick small wins, and especially getting the localized environment working, because most of the time when developers start at the job, it takes days, and now you have this environment containerized and they can start coding on the day one. And being able to put this on your CEO's laptop, I don't know if that doesn't win the confidence, I don't know what else would. So that we try to follow similar strategy with other companies. So maybe we can move on to after the localized environment was done. How did we start working on the cloud side?
Sure. Well, what we had to do is basically say, okay, now that we know everything's what's possible, and we had an idea of where the hurdles are going to be, and we basically said, hey, the whole R&D team is going to work on this. How do we want to design this process? And we had, which was, basically how do we build out the infrastructure to handle all of the various components that we're going to deploy. And so, one of the big decisions we made initially was that we were going to treat all of our configuration just as if it was application code. And so you can see here, for example, with the yellow dot, that when we commit configuration, it goes through our standard pull request and merge process that we use for our application codes, where we have to have multiple reviewers, it has to pass a pull request based build, and that it then has to go through and get deployed into a test environment where we run some additional testing to make sure that everything's good before those changes make it into production. And so we've actually since this come up with 5 new revs, but you kind of have to start with what is your goal and where are you going to go with this, and then from there be willing to iterate on it once you move forward.
Right. And Jared, I've been sysadmin for 10 years. Building something like this, for example, we have ELB here and a bunch of other services. Building something like this required a lot of approval process. Took months to get the hardware to to be able to innovate and architect infrastructure like this. So I think cloud, and I'm sure you would agree, cloud has been a major contributor to our journey here, right? And maybe we could talk about some of the how cloud has helped you with all the initiatives so far.
Oh, absolutely. I mean, when you're going through all this initial setup and trying to figure things out, one of the things that Docker containers, or containerization provides you is the ability to have an immutable environment. So that every deployment has the same known starting point. And that was really big, but you got to figure out how are you going to start this out. And so we did is we began with converting all the test and development environments. And so the first consumer of this DevOps pipeline was our first customer, I should say, is our QA environment, our QA department. And so they were able to use the tools just as production would. And so we caught a lot of issues up front and actually figured out a lot of configuration stuff that was kind of like in the heads of people, and actually had it now part of our code base, both on the configuration side and on the application side. But also tried to figure out like what makes sense from a deployment perspective, right? So when we started with the initial DevOps plan, we said, hey, how do we, how are we going to approach configuring all these applications? And there was a lot of ideas with doing, all kinds of fancy key value stores to modifying them. And we kind of said, hey, let's do what gets us started so that we can at least get on this journey, and then figuring out, hey, what can we do along the way to keep improving it? So it's not about it being all or nothing, like, okay, boom, everything's there. But when we started out, a lot of this stuff was just running on EC2 instances that we were basically managing our own Docker on. And then, in that transition period of time, we actually kept our legacy platform up and running until we were able to gain confidence in the new tool set.
Yeah, and I know one of our lead engineer from nCloud side has spent a lot of time with you guys on building the localized environment and also helping you to set up this cloud infrastructure for to get this testing going.
Absolutely, and matter of fact, one of the things that that nCloud was able to help out so significantly is that as we're going through this process, right? There's a lot of work in here that takes more than one person to do, right? We literally had our whole R&D team working on this for 3 months, and what was really beneficial to have your guy from nCloud there was to sit there and as we hit roadblocks and going, hey, this doesn't work exactly like the documentation says, or hey, guess what? There's no documentation for this. Especially in the early days of Ansible, there was some documentation that just was inaccurate or unavailable, and having someone that had been through this before and could give us that knew the ropes was a huge accelerator, because instead of us having to spend all the time to try to figure that stuff out, you guys are always available via Slack, where you can just say, hey, what's going on? Why isn't this doing what we expect? And then as we started to get to the point where we're rolling it out and looking to move to production, how did we to handle when there was an issue came up, is that you guys are always there to kind of jump in and give us a hand. It was kind of like having an invisible operations team that could jump in and pinch hit when something got out of control with these new tools. Which as you're learning the ropes and what's safe and what's not safe, you kind of hit those bumps and bruises. But the good thing is that we've had your guys' support to really make it through.
Yeah, awesome. And also, because we've done this many times, that's why we try to leverage the right tool and focus on how can we get you there faster, right? Maybe we could talk about some of the tools we leverage, like ECS, Lambda, and Route 53.
One of the things I mentioned is about the whole modernization piece, and one of the big pieces that is kind of overlooked a lot when you're doing these is that, especially for QA environments or development environments, you need to be able to like spin them up quickly and burn them away when they're done. And that pretty much, almost killed the first time that we tried to do this DevOps initiative. Is that before I joined, they tried to go to AWS, and they kind of didn't get the concept of how important automation was, and right-sizing what you're deploying, and then being able to quickly configure it. And so sometimes, because of the old configuration style, they would spin up a whole bunch of systems, and it would take them, a week or two to get everything configured before it came up. But because of that, no one wanted to shut stuff down. And so with this, once we were able to script out all of our Route 53 entries, that made a big difference in how we're able to, configure, and the speed and deployment. That if we needed to test something, we could just spin up a new config, start working on it, and because we had a known nomenclature for how we describe our API endpoints, people were able to pretty easily connect to a new environment and do some testing on there, and then when we're done, burn it off. And then, I think Doug will cover this a little bit more, but one of the things that's been really powerful is that as we've done that, now it's given us the bandwidth where it can just start to do modernization. And so we started to take advantage of ECS, especially with our build environment, where initially we had dedicated EC2s that were just running build, and so we had a very specific number of build that we could have in progress in parallel. But as we were adding CI/CD to the pipeline, that means there's tests that need to occur with every pull request to make sure that the code is functioning correctly before we merge. And so that was one of the big things, is scaling it out so it auto-scaled. And that way, as engineers are working on stuff, there's no delay as they're producing code. They can basically say, hey, is this good? Well, let me just do a PR real quick and I'll check. Instead of like, well, let me review this a little more, let me spend more time, let me try to do this test. Now they just issue a PR, they get those results back right away. But also, the other thing is, as our products are now containerized, we've been able to modify those applications to support being deployed in an ECS cluster, and then being able to be scaled out. And then the other piece I think would be good to cover is around Lambdas and how we've been able to use those to get information about how the environment works. And Doug, maybe you just want to cover a little bit of what those products do, and how Amazon offers those.
Yeah, I'd be happy to. I mean, one of the biggest goals for us at Amazon Web Services is to provide services that allow businesses to really focus on what they need to do as a business and not worry as much about running the IT infrastructure. And as you guys saw, and as you mentioned, with running a ton of EC2 instances, you're still dealing with all that configuration, managing those virtual machines. And so our large ecosystem of products allows you to run services and really focus on what you're running on them and not on running the services themselves. So the EC2 container system, or service, or ECS, it's a highly scalable, high-performance container management service. And basically it supports running Docker containers and allows you to easily run those applications on a managed cluster of EC2 instances. And the goal there is to eliminate all the need for you to install, operate, and scale your own cluster management infrastructure. So you just launch the ECS cluster. We take care of scaling that cluster up and down, all that work for you, and just simplifies the overhead and not having to have resources spend all their time actually installing and configuring and playing around with Docker container management systems. With Lambda, we kind of take that even a little bit further and allow you to run code without thinking about servers at all. So you're paying for only the compute time that you consume. It lets you run code without provisioning or managing any servers. And there's no charge for when your code's not running. So you just deploy your code into Lambda. You trigger it based on events that you define, whether it's items thrown in an S3 bucket, web calls that you make to it, items in a queue, things like that. The code triggers, it runs. While it's there running in memory, you pay for the time, but you're not paying for servers to sit there waiting for things to run. And it's kind of enabled a lot of cool little scripty things that you'd normally have to have servers in there running that you probably wouldn't have taken the time to write or thought about doing and incorporating into your business flow because the overhead was a little too much. And I think Jared will give some great examples of how they did that a little bit later. With Route 53, it's a highly scalable and available cloud DNS system. And one of the big things there is not only does it save customers from having to run a DNS system, have servers out there in multiple areas that can respond to DNS requests, handle all that load, scale up and down, but it's also designed to give developers and businesses an extremely reliable and cost-effective way to route users to the internet applications, as well as to be able to change those DNS entries dynamically, as Jared mentioned. When you're running a name server, not only are you running well and everything, but if you go to start having your apps automatically change DNS things, there's a lot of scripting and a lot of programming that gets involved with that if you're running your own name servers. With Route 53, everything's exposed via API and SDK. It really lets you be extremely fluid with how you point those records, how you modify them when you add them, when you change them, and basically comes down at the end of the day, once again, just trying to make things a lot easier for developers and business folks to be able to focus on their business and focus on their customers rather than on the infrastructure.
Yeah. So Doug.
Yeah, I think one of the.
Go ahead, Jared. Sorry.
Oh no, I was going to say to carry off of your point there. One of the big things that we initially use this for is being able to use Lambdas in combination with Slack. If you guys can go to the next slide, to be able to get quick diagnostics on an environment. So when you're going through this process of trying to set up a new DevOps pipeline, and you're playing with the configurations of all your applications, it's really important really quickly to get feedback on, hey, is everything running correctly? And so this is where we're able to use Slack and Lambda to do a quick query of all the health interfaces of our applications and say, hey, is everything running as we expect? And if something's not, we're going to do additional queries to give us detailed metrics on what's happening within those services. And so this is like an example of something that, even though the core application is not using those services yet, we're able to kind of get our feet wet with those, figure out how they work, what's the best way to use, deploy, and all of those things, and also provide value to the organization by having a tool that now are, both operations and even developers, as they're working on an environment, they can quickly go and right from Slack query what's going on. Or if a support notification comes in that, hey, there's some sort of issue, now instead of them having to go rip out their laptop and log into something or pull out apps and log in there, from Slack they can do a couple of quick checks and say, hey, does it look like everything's running? Or, it allows us to get to root cause on issues a lot faster.
Yeah, and you have the context right there, right? And DevOps is all about collaboration and people working together. So especially as alert come in, you can talk about it. It really, really promotes the collaboration. And I actually wanted to talk about one more point you had on your previous slide, that Route 53 allows you to cut costs because we were able to script a lot of the stopped instances and move the DNS around. And I feel like cost is a major issue for most of the companies on cloud, and most of the time the reason is that they end up using the cloud just like they were using the on-prem environment, and that's why maybe they end up paying as much as on-prem. So by leveraging the right tool for the right job and truly believing in automation can really significantly reduce your cost and also help you with innovation. Jared, maybe we can. So we leverage all these tools now. Every company end up building CI/CD pipeline, and I was actually listening to Jez Humble's keynote the other day. He was mentioning that companies like Netflix and Google, they deploy code 1,000 times a day, but the quality is still there, right? So maybe we can touch on how we make sure, even we're going to be deploying code frequently, the quality is still there. So maybe we can transition to CI/CD and talk about that.
Yeah, so as I mentioned, the chatbot is one area we've done that. But one of the things we had to do was, as we're deploying this, a lot of the tests have been set up as either like JUnit or a Mocha Chai test that only ran at build time, or we had black box testing that was done by QA people once an environment was fully deployed. But we kind of needed something like in between, right? So that as developers or as operations was initially deploying a new configuration, we needed something that kind of gave us quick feedback that, hey, it looks like everything's there. And so we did like literally a one-day workshop where we went through, outlined all of the core APIs that gave us a good indication of what was going on, and we found like 36 of them that, if we ran through those APIs and they functioned a specific way, we had a pretty good degree of confidence that everything was deployed correctly and everything was running, that this was a good build and a good configuration. So once we discovered that, we actually built a couple of really quick automations within Robot Framework that allowed us to instrument all of those APIs across all those different types of systems and give us feedback within seconds about whether or not an environment was deployed correctly. And so that was kind of like the step one to this of, hey, let's make sure that as we deploy stuff, it runs automatically. And then once we had that, we were able to expand it to include new test cases, and then, so we found the first 50 important areas, and then we expanded that to the next 200, and now here a year later we've got literally hundreds of test cases in there that run whenever we do a build. So obviously it takes a few minutes to do that, but now we're basically doing a full regression on every pull request, so the likelihood of issues getting in there is significantly reduced. And as we learn about issues, like something happens, then we go back and add in regressions to cover that particular use case. So the goal is not necessarily to do every possible test that's available out there, but the idea is to hit, as much as makes sense. And then using the tools you see here, where we actually have Jenkins with Tower that actually automates all the deployments going into there, so that when a build occurs, the developer doesn't even have to go and log into those tools. they're all instrumented behind the scenes based on when they do a pull request. And we use a lot of Lambdas now to actually control the execution of both our unit testing and our CI testing that occurs during builds. But one of the things that's also been really helpful is that as we're starting to use Lambdas more in our production services, is around how CloudWatch actually maintains transactionality in execution. So a lot of the logs for our front-end APIs, it's all time-based. And so as multiple instances are logging, in order to keep track of one conversation, you have to do a lot of filtering. And we've got a bunch of different tool sets in place to do that. But with the CloudWatch, we're able to get to the point where we can actually see the a single transaction that took place in one spot. So it saves us quite a bit of time in trying to track things down. But I think the important thing is that this isn't an end journey, right? Like there's tools on here that were not part of the stack. I mean, we weren't using CloudWatch and Lambda more than a year ago, and now they're an integral part of what we do. And there's going to be tool sets on here that are being deployed that will be available within the next year, and they'll sunset other stuff in here. So it's an ever evolving journey.
Yeah. And most of the time we try to leverage these tools for our customers, especially CloudWatch, and maybe Doug could speak on that. It makes it, if you're running ECS, it makes it easy to just pipe the logs there and just to store metrics. And Doug, would you mind speaking on CloudWatch for a few minutes, maybe?
Yeah. So CloudWatch is really an integral building block service to our AWS ecosystem. And it's basically a monitoring service for AWS cloud resources and the applications that you're running within AWS. We can actually take custom metrics in directly from your app through the SDK and API, as well as monitoring our own resources within AWS. And you can use it to collect a ton of metrics all over the AWS infrastructure, collect and monitor all of your log files, set alarms. And one of the biggest things is it allows you to automatically react to changes in your AWS resources. So things like auto-scaling groups can be affected by CloudWatch alarms automatically, so that you're not getting a CloudWatch alarm or some form of monitoring alarm saying, hey, my infrastructure is being way overutilized here, I need to go scale up. Instead, CloudWatch throws its flag to the ASG, and the ASG goes ahead and scales up, say, your ECS infrastructure, or adds more instances behind your ELB, or if it alerts that, hey, you're wasting a lot of resources, it can scale that down. So CloudWatch really allows a lot of that great functionality and integrates a lot with all the tools. I mean, one of the great things about the AWS ecosystem is not only the tools that we provide, like CloudWatch, but our extensive partner network of solutions, some of which are listed right here with Ansible Tower, with Jenkins, or the expertise that you guys provide at nClouds. And that being a giant part of the system we provide is actually our partner network, as well as our tools like CloudWatch.
Great. And Jared, I remember when we first engaged with you guys, the testing used to take days, right? And we actually worked together to cut that down, and that really had a huge impact on how being able to deploy constantly, because you want to make sure there's a certain level of confidence. So can you talk about the initiatives we did on the testing?
Yeah. So as I talked about on the smoke test side, that was how we started. But now, we have to actually get to the point where we say, hey, how do we get to a level where we can do, have a certain degree that this PR that we're going to introduce, even though it's affecting one area, it doesn't affect something else. And as we were building up new microservices, we still kind of had to bring our legacy applications along. And so we added, a fair amount of regression testing that was available, and tried to integrate it in with our deployment pipeline. But set it up so that it's something that can occur quickly, and that anyone can run. So initially it started off as just some Docker containers that would get built and deployed, and it had to be kind of all run within Jenkins. But now it's actually set up so that people can run it from their desktop. So as they're doing development, they can just trigger it off locally. But I think another big piece of the automated testing that we needed to do was around performance. A lot of these applications, actually most applications in general, respond a little differently to load or to various load events, both when they're in AWS and when they're in Docker containers. And so it's important to kind of outline, what are the performance characteristics of each application component. So for example, when you're sizing out, what do we have, what instance size do we want to use for ACS cluster, or how much do we want to provision for a certain service, to kind of leave as both baseline and what do we use as scalability benchmarks. The only way you can really figure that out is by actually testing on them. And not only that, is depending on your application, you may get more performance from having, a lot of smaller instances and more of them versus having larger instances and less of them. Or depending on your traffic, if you've got enough traffic, you may say, well, no, it actually makes sense for us to have a bunch of larger instances. So trying to figure out where that spectrum is of do we go with larger instances hold more traffic, and so each scalability shelf is a little taller, versus is this a service small enough where we deploy smaller instances? For example, like we got some services that get deployed in ACS with clusters that have like a C4 4x large, and then they scale up and down based off of that. But we've got other services that are a lot smaller and are pretty much idle a lot of the time, and so we use literally T2 larges for those. Now that means that when it scales up and when there's something happening, it may go into dozens of those. But that way, since it's a very seasonal how it operates, when it's not doing anything, it's sitting there with one EC2 instance. And so that actually helps a lot in managing cost, is around doing that performance testing, really understanding both where your application runs well at and where it where it doesn't. One other note I'll add on here is that if you're using instances like T2, it's not just about, hey, does the application perform, but you also want to manage your CPU credits, right? Is it one of the benefits of having these the T2 instances is the ability to do bursting, so you can absorb small amounts of traffic without actually having to do scale events. And but it's really important that you manage those, because if you don't watch your burn credits, how many credits you're burning through, then you can run into some issues after you burn through them all. So that was I think once we figured that out, because that would allow us to transition from having a lot of dedicated M series and C series instances where we would leverage T series instances a lot more for our ECS clusters, and really get to the point where we could manage our performance much closer.
Yeah, and it's just really combining the right tools for the right job, right? Combining all these different tools like Ansible, Lambda, and putting together a solution where you feel confident that each time you deliver code, it's gonna be quality software, right? And I think maybe we can also talk about the next, Jared, like some of the cultural changes we have to make, right? And sometimes that's the hardest part. Once you have all the tools and processes in place, now just believing in that process is hard for some companies. So can you talk about some of the things we did around culture?
Absolutely. I think the hardest part of this is, once there's this kind of tipping point where you build up the tools, you think stuff's going, but you still have this legacy environment you can rely on. As I pointed, when we're building up confidence, I said earlier on that we still had this legacy environment for like our QA department, and because it was a known quantity, people had a tendency to revert back to that when they were trying to figure out things. But we realized that once we hit our 3-month mark, we said, hey, what, this is something where if we're going to go all in on this, we need to do it. And so we took the nomenclature of burn the ships, and we literally just said, hey, we set a date, and all those environments got shut down. So now it was, if something's going to happen, it's going to happen with the new tool sets. And I think that was a really critical milestone within the organization, because being able to just say, well, okay, we'll schedule these on a schedule, or decommission these in a schedule, was something that there was always a reason to get it pushed out. Oh, well, this isn't done. Well, that isn't done. And you got to at some point kind of say, okay, we're all in on this, because if you got 1 foot in, 1 foot out, you're not going to realize the benefits of this, and you're just going to have a lot higher cost, because now you've got 2 environments running in parallel. So this is one where you really kind of just got to pull on it. The second one was eliminating the ability for developers to access and operations to access SSH. This one took a lot longer. I mean, it was probably a year from start before we were able to do this one. But that was also a really critical piece, because what ended up happening is that people log in and say, hey, what's wrong? Why isn't this working? So they'd SSH into an environment and try to look at, well, maybe I can just tweak this real quick and at least get it working. But the problem is that when you redeploy a Docker container or do a next deployment, then that change is not there. So, getting to the point where we could shut off that access and saying it's there only for emergencies and then actually pull keys, that was a really painful process to get to that point. And it's something that, we still have to have it there for emergencies, but that allowed us to basically force root cause analysis. And then the learnings that we figured out for both when in development and operations when something happened is being able to integrate that back into the tool set. And that what we would do is say, hey, if something happened, I would rather put through an emergency PR that gets reviewed by the team and get those integrated, and then we redeploy using the normal process. So now every deployment gets to take the advantage of that, rather than having someone go in and try to manually fix it, and then it gets a Band-Aid, and then someone forgets about it before we do the next deployment the next day. So I think those were kind of like the big, the big things is that culture change comes with making hard decisions, and these were probably the harder ones that we had to make. Is that we had to treat everything, even a failure in development, as a actual failure, and do root cause analysis. Because doing that there in development and in QA eliminates that from happening in production.
Right. And just sticking with that process, right? And as I mentioned earlier, some of these initiatives could take years, but just making progress along the way, each iteration getting better, that's really, really important. And you guys are reaping the benefits of that now, right? The impact on your business is amazing. And yeah, if you could speak on some of the achievements you've done, and you touched on that a little bit, right? I know customer confidence is up. So can you speak a little bit more about that?
Oh, absolutely. One of the things that had to happen whenever we did an upgrade was it required extensive scheduling with customers. Because customers, they were concerned about upgrades and going, hey, is this going to negatively impact our user base? So we had to do a lot of scheduling. It was a big deal. They wanted assurances that certain things were happening. Well, once we had this in place, now, hey, upgrades became a non-event. There's something that we do on a regular basis. Every week, you're going to get pushed to the latest version, and you don't even have to think about it. And so now it's, things can happen, and even if things break, it's like it's not as big of a deal, because customers can come back to us and say, hey, guess what? This isn't quite working the way we want. And we say, okay, no problem. And depending on how important it is, we can inject it into the pipeline and say, okay, let's get it in this week, so it gets through dev and actually out to the customers. Or we can say, hey, look, this isn't that big of a deal. We'll catch it on a future sprint as as we have time. And customers are more willing to kind of work with us, because they're saying, hey, look, we can see that we've done a good job of managing their expectations around this. But also having this gives us the bandwidth to do modernization, because the quality was there and reliability in how we deployed. Now, instead of our development team helping operations fight fires, they could actually do what they're hired to do, and that is build applications. But also do modernization, because now it's easy to quickly deploy. We can sit there and say, hey, let's try to test out various configurations of the tool, quickly move or part off things, and be able to deploy those without having risk that we're going to make a change that's going to be backwards breaking. And so that's really helped us gain a culture, a true DevOps culture, that allows us to have speed, and in a way made us very attractive. That made it so that Prudeo was interested in acquiring us, and then they actually did.
Yeah, that's great. And one one thing I think is worth mentioning is, and I get asked this question a lot, is companies often wonder when can they have that checkbox and say, hey, we are doing DevOps. But I think they're missing the key point is that DevOps is all about continuous improvement. I don't think this is something that ever stops. So we'll continue to. We're excited to continue to work with you at your journey around DevOps at Perdea as well. And as you say, DevOps is a force multiplier, right? This is something you constantly work on and constantly get better. That's the only way to get a competitive advantage, right?
Absolutely. I mean, we took a hit initially to, we'd stopped our roadmap to get started on it. But absolutely, it's got to be looked at as something that it's now part of your culture. It's something you do. Just like you have a developer, just like you have a product manager, just like you have an operations person, there's got to be that DevOps proficiency in there. And it should carry over to your various organizations, right? I mean, it shouldn't be only, one person assigned to that stuff. It needs to be integral so that, your engineers, the software developers, are actually familiar with DevOps and are working with the tools. You want to kind of make it so that it's not siloed, but everyone's familiar with that.
Yep. And hopefully, since you have a data point at Arrayent, it makes your job easy to replicate this at Perdea. And Jared, I want to thanks to you, and I want to say thank you to Doug for joining this, and Jared, thanks for sharing this amazing journey. And we're really excited.
It's been fun.
Yeah, we're excited to continue to help you with at Perdea, and partners like you really help us to really stay true to our mission of empowering and delivering innovation and bringing predictability to operation. And I hope everyone here found the webinar useful. As Ellen mentioned earlier, this is a series. The next one we're doing with Informatica, and the next one after that will be on December 5th, which is to be announced. But please save the dates. And Ellen, let me hand it back to you for any for Q&A.
Thank you. Hey, guys, that was, as JT mentioned, great job. Great job. The audience always wants to find out more about AWS. So many of our listeners and readers are also AWS users. But what really brings it home is when you have someone like Jared, who's actually, who's lived this and has done, has been through it. It really, there's no substitute for experience. But let's jump into a couple of questions here. And there's still time if you want to type your questions in. We have a few in the queue already. But first one comes from Ed. And it's really, I guess, Jared, for you, and that is, what did you use for performance testing, JMeter or something else?
So we used a couple of different tools, but what we ended up doing is we actually built our own based off of Grafana, and what we ended up doing was adding in StatsD to a couple of key areas, and then streamed off there. And then we also looked really carefully at the AWS metrics for what it said the instances were performing at. And using a combination of those, we were able to basically build out a spreadsheet that said, how many connections or how many users or how many devices could we support per instance. So yeah, it was mainly Grafana with StatsD is what we had used for that.
Good. Our next question is for Doug, and it comes from Deb. Deb asks, how do I manage my container images on AWS? And of course, Doug, I mean, containers, this whole container thing's kind of blowing up. We're seeing usage statistics that kind of dwarf VMware adoption back in the day. So how do we manage container images on AWS, Doug?
Yeah, I mean, that's a great question. It was kind of one of the things that we realized as we were building ECS was that we had to have some form of resource in order to manage all these things, which is where the Amazon EC2 container registry, or ECR, comes in, which is a fully managed Docker container registry, and it makes it easy for developers to store, manage, and deploy their container images. It's very tightly integrated with the EC2 container service, or ECS, and it kind of allows you to simplify your development workflow, eliminating the need to operate your own container repositories or worry about scaling that as well, and takes away yet another resource that you have to manage. And so it allows you to host all of your own images, as well as there are public image repositories there for you to grab things and collaborate with.
Got it. Got it. All right. Next question is also container related. I'm going to throw it at JT, but Jared, interested in your take on it as well. What are the key challenges to take care before we move to containers? Mostly our own apps. Bhargav asked that.
Yeah, so as we mentioned earlier, being able to bring up, like, let's say, a localized environment, just get something working before you start exploring like schedulers like ECS or Kubernetes is very important. It's very important to get to a point where you can say this app could be containerized, and using tools like Docker Compose, which is what we use for Arrayent, could really help you to gain that confidence that, hey, this app can be containerized. And once you have the app containerized, then you could focus on spinning it up on like a dev environment and a QA environment. That's what we did for Arrayent, and we actually let that environment sit for a while and did testing to make sure there aren't any issues, and then we took it to production. So I guess the answer will be take one step at a time. And once you have your localized environment, this is something you can use. You can give it to your developers, and whenever developers start coding, they can bring up their local environment, and you already are gaining benefits from that. And then you move on and build QA, staging, and production environments. So the advice would be to work in iterations.
Very good.
Actually, I have a point on that. I think I'd like to add two quick points, and that is, one is try to treat your containers, at least your application containers, as immutable objects. What you don't want to try to get into is trying to adjust the configuration inside the container. If there's configuration that needs to be changed after the app is deployed, work on getting that into the application, or find another tool that does that. But you don't want to have something that's modified container inside the configs. As a stopgap, because our applications did require local config, what we ended up doing is creating a separate container that we actually had our configuration files, so that we could actually build multiple versions of the configuration, and it was just a matter of deploying them using Compose and doing a link between them, so that we could actually then load different configurations. And that allowed us to still treat our applications as immutable. Now, one other point is around the variable management. So a lot of times configuration files that developers make, especially if there hasn't been tight control from product management, they'll have a lot more knobs than you really need. And so, they'll have, like, literally we started with 500 variables across all the configuration files, but now to deploy an environment, we have 5 variables you set and everything else is generated. So look for tools like Ansible, but once you get that initial prototype done, figure out what variables can be inferred based off of other variables that exist, right? So for example, if you have some way of naming an application, use that application name with like a suffix or prefix to name key spaces in Cassandra, or name log files or other stuff, so you don't have to maintain other variables just for those. And so I think those type of things, and realize you can automate the automation, makes a big impact as well.
Excellent. Let me throw one at back at Doug, actually. I don't know if this might be too, I don't know. But Doug, again, as Jared mentioned a couple of times about only paying for what you use in regards to AWS Lambda. So how is Lambda priced so that you can pay what you use for what you use?
Yeah, so like most of our on-demand services, Lambda has based on on-demand pricing. So you're charged for the total number of requests across all of your Lambda functions, and it counts the request each time it starts executing in response to one of the events that you invoked, or a call that you invoked to it, which does include test invokes from the console. But kind of neat part is that the first 1 million requests every month are actually free, and then it's about 20 cents per 1 million requests thereafter. But then there's also a duration that kind of calculates into that as well. So the duration is calculated from when your code starts executing until it returns or otherwise terminates out, and it's rounded up to the nearest 100 milliseconds. So the price there kind of depends a little bit on how much memory you allocate to it, and you're charged a fraction of a cent for every gigabyte second used. If you go to the AWS site and click on the Lambda page and the pricing page, there's actually a great table there that shows, by RAM how much it costs per time unit that you're using, and gives some great examples of how to kind of calculate that out for your solutions and for your functions.
Yep. Excellent. All right. I got one here for you, Jared, from Conrad. How did you manage branching? Do you consolidate the branch daily?
Oh, that's a really good point. So actually, that's probably a topic we probably should have covered a little more in depth, but I'll try to make it quick. So we have one branch, and it's master, and everything goes into it. That was one area which is another big pain point for the team around software development, is like getting to a web-based release strategy versus a typical like what you'd use for a desktop or server-based release strategy. And that was really hard, and there's a couple of areas that we had to change how we do things in order to do that. One was around the automation for pull requests, right? That wouldn't have been possible without having pull request-based builds checking each release and doing testing on them. That was requirement number one. Number two was that for features that are not quite ready, you need to have feature switches, right? So rather than using branches, we use feature switches now, so that every application that gets deployed has everything. And so, that way, if you want to have someone test a certain feature that's not production ready, they can actually use a feature switch to enable that. So I think the combination of those two is probably high level what those are for. They probably are the big ones. I'd leave you with that, is that those are probably our two biggest points.
Got it. Another question here is also from Conrad, and it's about, I guess he was unfamiliar with the dev culture change. JT, you're a DevOps person. You want to explain what we mean by that?
Yeah, it's going back to as we were talking about earlier, just working with the team, and especially what we did for Arrayent is like work with Jared to implement a better culture where the process we implemented, we wanted to make sure everyone believes in that process, right? So that means no SSH access, but that doesn't mean that no debugging. You have to build orchestration where getting access to logs is easier. So it's just figuring out how we do things and making it easy where we all are working together the same goal, which is how can we add value to the customer fast, and making that process efficient. And once you have that process built, really believing in it, right? Because it's when things get a little hard, people get used to, they go back to the way they've been doing things, right? So it's a process that takes a while, but you take one step at a time and keep improving in every iteration, and slowly you get a well-oiled machine. You have a team which is well aligned, and amazing things happen, as we saw at Arrayent and Perdea.
Absolutely. So, guys, we're coming right up here on top of the hour. I wanted to just take a moment. First of all, again, thank all three of you for a great job. Thank everyone for listening. Big reminder, hey, this is just the first of three that we're doing on CI/CD, Containers, Cloud, and Culture, our 5C series with our friends at nClouds. Sign up for the other two right now, and we will have you on the list for that. But that's going to call a wrap on today's webinar. We're off to a great start in this series. Looking forward to the next two. Gentlemen, all three of you, thank you very much for a really great webinar. Thanks, everyone, for listening. This is Alan Schimmel for DevOps.com, and we'll see you soon on another webinar.